First of all, what a pleasure to be here today. I think I've been at every Serverless Days Cardiff. Apologies if I have missed one, but it's always an awesome event to see such a mix of customers. I love that there are, students and startups, but also, the really sort of big public sector organizations. And as we've seen in the talks today about how they sort of really leveraging serverless for some super important things. So, yeah, let's get going. I'm actually going to be talking about, as Matt said, about Lambda things that are going to be coming. Whole bunch of demos, hopefully some interesting stuff, which you may have not realized because there's a lot going on all the time. But just before we get started, a bit of a hands up. Raise your hands if you actually spend more time as a software developer debugging code rather than actually architecting it. Yeah, we got a few hands. So the sort of idea is that one picture on the left-hand side is how sort of developers really want to feel. But I don't know about you, and maybe it's just me and the terrible code I write. My software development experience is often on the right-hand side, and I'm, fighting tools and fighting debugging and fighting what's going on. And sort of this is for a good reason, because you have the sort of expectations. You maybe even vibe coding an app, and you want to build something. You're all excited, and the reality hits in, and it's deployment and testing and tooling and all these other kind of things. And I think particularly in public sector organizations, there's a lot of organization inertia and security checks. And some of them are good things, which you actually see are important. And some of the other things you just think is unnecessary. But that's the reality of how developers feel. But actually developer experience, how developers feel, is important. In this Deloitte survey, companies focusing on best-in-class developer experience get 60% higher revenue. And you think, wow, that must be crazy. But then if you think of it, well, if developers are being able to be more productive and to be able to do more things, they can ship code faster, they can try new things out, they can do more. And so you would hope that, yes, of course, revenue would be higher. So yeah, it's an interesting correlation to take that correlation of how productive and useful your developers can be all the way up to how long it takes to get stuff in production and ultimately for your companies to make some more money. So this also harks back to why we even do this in a serverless way, and how does serverless work into this? And the whole thing I always say is serverless is actually just about a faster way to get time to value. If you're not looking after infrastructure, if you're not doing a whole bunch of unnecessary stuff, it's going to be able to try those ideas quicker and all these kind of things. So there's a direct correlation between developer experience and getting things done faster. And serverless, in my opinion, is the fastest way to do that. I didn't introduce myself. My name is Julian. I do work for AWS. I've been there for just over 6 years. As I said, been to many of these serverless days, and particularly Cardiff. So I work on two sides. I do presentations and talks and blogs and videos and things, but also actually work really closely with the service teams to make sure that we are building the best serverless products and features that will help you. So, please come up and tell me your gripes, tell me your questions, answer anything. I've got some awesome colleagues at the AWS booth as well. Hopefully you've seen Serverless Espresso and enjoyed the Hardlines coffee. I've had people come up to me who, I don't know if it's that really serious, but they probably came today for the coffee, and then, there's some talks they need to listen to as well. But yeah, we're happy to answer your questions. I've spoken to already a number of people today. I've got some good insights to be able to send back to product teams to be able to help them build better things for you in the future. So, the daily life of a developer about building cloud applications. There are obviously also many places they need to work. There are many things they need to do, and they want to be effective. And there's sort of two parts they sort of think about. One is the said inner loop, and this is a sort of high frequency, rapid kind of changes. You're on your laptop, on your workstation, you're doing locally, you're writing your code, you're running it, you're testing it, and you debugging it. And obviously you want fast feedback in seconds or maybe minutes if something is a long process. But, it's really critical that developers' productivity and satisfaction is optimized for this part to make it feel as though you're not wasting your time. And then the outer loop is, well, you sort of send that off to somewhere else. So maybe that's going to be a CI/CD pipeline, or it's going to be some reviews, or as Jan said, it's maybe going to be some, AI code reviewing, those kind of things that as it sort of goes through the system to get out into production. And that's also as important, but that's a sort of often a bit more of an async process when the system is handling the code that you've done. So it's a sort of connection between the inner loop and connection between the outer loop. And obviously, this is even way more apparent with serverless because there are far more services and there are obviously many more things to look at. Simulating cloud services locally, that can be a bit complex. There are function execution differences between your local and your cloud. You've got different dependency management, limited offline development capabilities. So yeah, when you're dealing with serverless, the sort of inner loop and outer loop, I think is sort of exacerbated a bit just because you're dealing with more stuff. And so there's something up here. My laptop screen went blank. Hello. Oh, there we go. Debugging production. There we go. And so, with serverless, developers need to work in two places. Obviously, we're talking about on your laptop, they're developing the cloud for the cloud, but they're obviously working locally or in the cloud. And there's sort of pros and cons with both approaches. And, this doesn't quite directly correlate to that, but, when you are working in your local laptop, it's normally in your ID, or if you're doing some stuff in a terminal, or maybe it's in some sort of coding assistant. And then also in the cloud, when you're doing things, forget all the deploying side, but your interactions with the cloud is obviously in the AWS console. And, the pros of working in the console, zero setup, it's all there. It's all nice and visual, so you can figure things out. What you see is what you get. There's monitoring, logging, and sort of IAM testing built in. And obviously, as AWS comes out with new features, they are just sort of there. But also, there's some cons against this approach because it's a very manual operation. It sort of resists automation. There's no version control that you've got. It's hard to collaborate between teams. It's also sort of slow feedback, particularly if you need to upload artifacts. And there's obviously the bigger risk is this configuration drift between environments. If you, jumping to 5 different Lambda functions between your dev, test, UAT, and prod, there's a risk that things can be different. And then on the local IDE side, well, you've got PowerFile IDE editing, you've got code completion, you've got AI tools, all the cool kind of things, integrated debugging, what have you got? You've got checkpoints and inspection, you can do all the kind of things, but, quality tests with frameworks and testing and infrastructure as code, those are all the cool things. But obviously, there's a lot more to set up and to get going. There could still be environment differences, particularly between your cloud and your local environment. Simulating AWS services or using mocks is something to keep in touch of. And obviously, if you're doing IAM permissions or things like that, that complexity is just a bit difficult when you're doing things locally. But actually, as developers, we actually want the best of both worlds, or at least an easy way to transition between the two, when we can sort of love the different ways and use the best parts of where we're working, but be able to connect them together. And there's a sort of third leg of the stool where we actually really want to try and get to infrastructure as code as quickly as possible. Whatever you're doing, infrastructure as code, I suggest use a framework. We've obviously got AWS ones, but there are many third-party ones as well. And this is really going to give you superpowers to be able to build serverless applications. And it's not actually just about having your configuration in code. It's all about being able to create ephemeral environments and be able to have the same code in development and in production, and to be able to have your software development pipeline. So infrastructure as code is super key. And you can sort of think of it as sort of this crawl, walk, run, fly evolution, using the different tools to be able to get to the sort of the nirvana of being super efficient building your applications. So, anybody keen on some demos? Should we see how some things work? Oh, good. Good. Just checking. I'm just slightly worried. It's after lunch. People having a doze. Hopefully, you've had a coffee. The lights went down, so people can slightly sleep without me noticing. But hopefully, the demos will bring it all to life. So let's look at the management console. I'm just going to look at the screen behind me because it's way too small for my old eyes on the laptop. And so if we were starting in the Lambda console, I've collectively created a new function, and it has the VS Code code editor within the local, within the cloud environment. And you can see I have my function code here. And I've actually got a big file. I'm not sure if you can see on the screen, but it's called big file, and it's actually got a package size of 11 meg. And this is super cool because previously, before we updated the console, you could only have a code size of 3 meg to display in the console. And that frustrating thing where you had a function and you opened up the console code editor. Sorry, it was too big to be in the console. And now, so it's actually up to 50 meg. Your whole package size can be 50 meg. And people do say, well, that's crazy. I don't have Lambda functions that are as big as 50 meg. No, but your Python or your Node dependencies can be up to 50 meg. And so we can display in the console any file size that's up to 3 meg for a single file, but the rest of your Node modules or your Python packages or whatever kind of thing that's there, you can see it. So that's also a quality of life improvement. At least you can see larger function sizes in the console. So next thing to look at is I can look at my, along the side, it's VS Code. I can look at the extensions. There's key bindings, Max and Emacs and Vim key bindings. I've got a whole bunch of settings that you can look at as well. The command palette is there. So it's just like VS Code, but up in the cloud. If I type for Lambda, you can see all the Lambda functionality that is available. I can also look at profiles. I've then also got some settings. This is just VS Code as you would use on your local machine, but all up into the cloud. Very importantly, obviously, I can change my color theme. So I could, switch to a dark color theme. And if I sort of bring that up to full screen, that looks very much like my coding environment in my laptop when I'm in a VS Code on the dark screen. And obviously, I can then switch it back to the light color mode. So yeah, super useful. The whole idea is that your local environment looks more similar to your cloud environment, and it all looks a bit more like Visual Studio Code. Now, I know the JetBrains people among you will be a bit frustrated and annoyed. Maybe in the future we will come out with this for other IDEs, but at the moment the functionality is for VS Code. But what has happened over the past year is there's actually been an explosion of VS Code clones from, Kiro from Amazon and from Cursor and from Klein and all these other kind of things. And because they are derivatives or they're clones of the Visual Studio open source version, many of the plugins also apply. So a lot of the functionality is also available for these new coding tools as well, which is super cool. So the next kind of thing, look at it. Oops, I did jump across. My clicker is not behaving today. Are we moving? So the next up we can do is environment variables. No, here we go. Wow, this is turning into a fun thing. We're switching back to there. We've got the settings, then into the environment variables. So directly in the console here, as before, you could add environment variables over here. So I'm just going to create a my variable, and I'm going to set it to an important setting, because of course it is. I'm then going to save that. And then when I then look down to see actually at my code, on the left-hand side, I've got the environment variables right next to me. So I've got the code on the right-hand side, and now I've got the environment variables on the left-hand side. So that's far easier than having to jump back and forth to be able to reference those environment variables as I'm doing my coding. So the next thing I want to do is I want to test a function. So I can click on the sort of test function button, and you can see a pane also opens on the right-hand side. So it's fully visual at the same thing. I can use some example test events. So I can grab one from API Gateway, for example, and then I can go and I can just change it to my heart's content. So I'm going to change the query string parameter just for my name. And this is now going to be an example event that I can now use to evoke my function. So I can save my function, and then I can click on the invoke button, and that's going to send that payload to my function, and I can see the results hello from Lambda at the bottom of the screen. So the cool thing about the test events is you can actually now share them as well. So you can share them between, so you can create sort of template test events, share them between other people within the account and within the organization. And actually, as we'll show later, you can also look at these test events locally, where you can grab them from the Lambda service and be able to use the same test events locally on your laptop. So coding with AI assistants, I mentioned a whole bunch. We've actually got Amazon Q's coding assistant fully built into the IDE. So you can see over here, I'm just doing a command, get API Gateway query string parameters from the event. And I just hit tab on that. And Amazon Q, by magic, just says, writes out the exact code that's going to be required to generate that as well. What else do I need? Maybe I'm going to put that in the response object. So tab complete, and it's just going to add that as well. And maybe I should also stick that, the event, I want to add the environment variable, the my variable that I set before. And again, Amazon Q is just going to write that exact, Node or Python or whatever kind of functionality, code to be able to do that as well. So that's just, obviously, if you know the code, you could write that yourself. But how much easier just to write a quick comment and off it's going to go. Now, it's obviously going to be more useful if you're doing something a bit more interesting. Maybe you're grabbing something from DynamoDB, or you're writing something to SQS or that kind of thing. It is able to, generate a few lines of code to be able to do that for you. Just makes your life a little bit easier using an AI assistant directly into the console. So the next thing we can do in the console is we can actually look at the live logs. So we can see on the left-hand side over here, I go to that setting, and I can then open the CloudWatch live tail. So what I need to do is I actually need to start the live tail, and then this is going to start streaming logs basically from CloudWatch logs directly here into my Lambda console. So you can see once it's started, I've clicked invoke a few times, and you can see here the events are arriving directly in the Lambda console. Now, you may originally think, well, hang on, when I did an invoke, that log was available already over there. But what happens if you are testing a Lambda function via a curl command, or maybe you're doing something with SQS or Kafka or some other event source or something via EventBridge, when you're not actually clicking on the invoke button to test that? So streaming the logs directly into the console, whatever way, shape, or form that you actually are invoking the function, the logs will appear over here as well. So there is a small additional charge when you do turn on the live tailing. But, I mean, to be honest, you're only going to be using it for a few minutes while you're doing some troubleshooting. If you do click away from the console, it will automatically stop. That's the live tail. So we've done a whole bunch of stuff in the console, but we obviously know we want to move towards the IDE to do some more stuff. So let's see what we can do there. So the first thing we can do is we can actually download the whole function code and an AWS SAM template. And this has got the infrastructure as code package, which you can unzip and you can use as well. But there's another way where you can actually just click a new open in Visual Studio Code. And you click on the button to confirm, and just give it a little bit of permissions. And what this is actually going to do, it is actually going to jump directly to Visual Studio Code where I've already authenticated. And this is going to download that exact Lambda function that you're running in the code. It's going to download it, and you give it a folder name, and it is literally just going to appear here on the left-hand side. And you can see how I have my function code and my handler. I've also got that big file.zip, which is downloaded. That's why it took a little bit more time to download. I can also use Amazon Q. So say I want to get my current IP address. I'm now using Amazon Q within my local IDE, and that's just then going to add that to the response body. The cool thing is here I can actually add dependencies. So npm install Axios, because I need to do Axios to get to check the local IP. And you can see it's using the package.json and has installed a whole bunch of Node modules. So that is all cool. I've installed this locally, but now what? Before you'd have to zip it and upload it. Now I click save. The local Lambda toolkit realizes that my Lambda function has been updated. And what it does is then it just goes and syncs up that package, zips it up automatically, including those dependencies and the new function code directly up into the cloud. So that is super cool. I haven't had to work out how to zip it and which is my root folder and do everything. It's just realize you've done a change on your Lambda function, saved it up and loaded it up into the cloud. So obviously, if I go back to my console, it says, oh, hang on, you have updated your code. Do you want to do a refresh, which you can easily do? And you can see I have, once it's refreshed, you can see I have, the updated code version for my function. I can then click on a test, and you can see I have the details there, which now has I can't see it on this screen, but the other screen's hopefully the current IP address, which was what I'd added in my function locally. So yeah, a really I would say a quick and dirty way that you can at least get your function locally. So if you have been developing your functions in the past in the console, a quick way you can get it locally. And then you need to do some quick iteration and everything. This is a way just talking directly to the Lambda service. But obviously, as I talked about earlier, infrastructure as code is our friend. That's really where we want to go. I mean, so in an ideal world, you really want to start with infrastructure as code, because it's going to provide that good practices with the configuration and with all the code from the beginning. The other kind of thing we can also look at in the console before we talk about that is the monitoring. So the monitoring tab has also been rejigged a little bit, and it's just got all your CloudWatch metrics. So you've got invocations, duration, and a whole bunch of things. You can see I can quickly look errors over here. I haven't had to jump to CloudWatch metrics itself to have a look. If we scroll down a little bit, we'll see we also have CloudWatch logs. So it's got the recent invocations and then also helpfully the most expensive invocations right there. And then even below that, AWS X-Ray. So it's got a service map of everything's happening. If I was talking to Dynamo, for example, it would also have that in my service map if I had X-Ray turned on. And then below that, it's got the individual traces. So I could then click on that and I'll be able to, open the individual trace for whichever one I was doing. So sometimes this gets buried. People look at the monitoring tab and they see the metrics on the top. Just scroll down. There's a whole bunch more stuff over there as well. And then you don't have to jump to CloudWatch logs directly or to X-Ray, to go and hunt around there as well. But also, obviously, all the additional information is there if you want to do. So we were talking about functions, building in your IDE. This is a really good place if you think about where you're actually going to start when using infrastructure as code. So the AWS Toolkit for Visual Studio Code is going to be your friend in all of this. And this is installed quite simply, as with any other toolkit, available not just for Visual Studio Code, but all the clones out there as well. You can see there's an application builder which arrives on the left-hand side. And this has actually got a new getting started experience, which allows you to make sure that all the tools to help with your local development is going to be set up. So if we have a look, you can see at the moment it says install the AWS CLI, click on that, install AWS SAM, click on that, install on Docker and click on that. And there's actually a fourth option for local stack, which is a local cloud emulator, which I'll cover shortly. So I've got all of these installed, but if you didn't have them installed, it just gives you a handy link to be able to install these kind of services and these kind of CLIs just to make your life simpler. So yeah, just a quicker way to make sure that you've all got the tools available. So what I can do as well is I can initialize a project. Let's say I want to build a REST API. Let's pick Python. Why not? I'm going to just pick a local file folder, and that's then going to download a whole SAM template, including function code locally. You can see on the left-hand side, I have all the folders. They're all available. And I've got my, a README file, which is explaining this little kind of microservice. Now, of course, this is just a demo application. At least it's a good way to start to be able to build your infrastructure as code. You can see on the left-hand side, I have the template file. So this is my SAM template, which is based on CloudFormation. There's just some metadata. I've got an event object that it's also downloaded, which is going to be helpful. And then you can see here, the application builder has started to be populated on the left-hand side. And so I've got some little quick action buttons where I can access, for example, Infrastructure Composer. And here I can actually look at a visual representation of my CloudFormation template. And I could actually even go in here and I could change one of the Lambda function configuration options, and that would then reflect in my CloudFormation template. So just another accessible way to be able to do that. I can also then open the function handler directly from over here, and then I can obviously go in and I can edit my function code. So yeah, this application builder, this is what's new that came out last year. And as you'll see through the demos, that's going to build, going to add some more functionality to that, where you're sitting in your IDE, you can use that application builder to look at what is in as a part of your application. So the next thing, you can also use the command palette as well, just as in the console. This is Visual Studio. So yeah, if I type SAM, it's going to give all the possibilities I can do with SAM. If I did Lambda, it's also going to have all the possibilities to do with Lambda. So just a good way to discover the kind of functionality that is available. So next thing, why don't we actually build my application? So what I can do, I clicked on a button and I can say, select the build flags over there. I like to do a cached and a parallel build. That's going to simplify things. I can save the parameters, and I can also choose to use a container. So this is actually going to download a container with all the build tools in it. I don't need to have Node or Python or anything installed locally. It's going to download the package and do the whole build process within my package, and then output an artifact which includes the infrastructure as code, the Lambda function, and any other kind of resources that are going to be built as part of CloudFormation. So that is now built, and all I had to do was literally click on the button, and I also can save those settings. So next time I want to do a build, all those settings are there as well. So yeah, that downloading container all happened behind the scenes because we had Docker installed. Super helpful, that particularly if you've got a different mismatch of tools, and you don't then have to have every version of Python or every version of Node on your local machine. So next up is we now have our application locally. We're building a little REST API. Of course, this could be your own application. We want to do some sort of local debugging, and then we want to deploy this as well. So what I can do over here is I can click on the local invoke button, and I could just invoke it from here as I did it in the cloud. What I can do is I could select that local an event object, or the shared one, or maybe from a local from the example ones, or I can actually open that local file from the event one, and that's the one that was downloaded as part of this template. So again, I could invoke, but what I can actually do is I can just save this as a debug configuration. So what it's going to do is I'm going to save that, and then this is going to automatically create that VS Code debug configuration file, a whole bunch of stuff, settings in there to be able to do it, and you don't have to create it yourself. It's going to do everything. So what I can do is I can then add a breakpoint within my code, and I can go back, and now I can invoke my function, and this is then going to automatically load the Visual Studio Code debugger. It does actually do a build beforehand, just in case you have any changes. And then once that is ready, it's going to use that launch.json file, and it is going to attach the local debugger to another Docker container that's downloaded, which is a Lambda emulation environment. And you can see it's now attached to that debugger. And now I'm sort of debugging my function that's running locally. So I can look at the context object, I can look at the event object, see everything that's passed to it, and I'll be able to understand what is going on. And then helpfully, I can also do a step 3 debugging. I can also look at the variables and step 3 debugging of my Lambda function as it's running in a local emulated environment. Here you can see the return object that is being done. And so, this is a really great way to be able to exactly see what's going to be happening in a local environment for my Lambda function. Now, I'm going to pause here slightly because although this debugging has been made much simpler and I can do the local invokes, also often people sort of forget maybe that a Lambda function is just Python code or Ruby code or Java code or Node code or whatever kind of language. And so you can actually use your normal Node commands or something to just run your Lambda function. You've got a handler function where your code sits within, but you can easily run, in Python, write a main object or that kind of thing to be able to just run it as normal code. Sure, you need to pass an event object in, but a lot of people forget that sort of step of just being able to locally run your Lambda function as if it was another kind of any kind of application that you run locally, because there's a lot you don't actually have to emulate Lambda. You just want to check the input object. You maybe want to do some data transformation and spit it out. You don't even need a Lambda emulation environment to do that. The Lambda emulation environment obviously is going to be useful if you're wanting to see and understand the context object, the formatting of an HTTP request, all those kind of things. But yeah, just remember, you don't always have to emulate Lambda when you are running your functions locally. So next up, we want to do and sort of deploy this function as a test function into the cloud. Two options. I've got sync and I've got deploy. Sync is the sort of slightly advanced, dirty option of being able to sync this function directly to the cloud. So I need to pick a region because this is going to do a CloudFormation deploy. I'm going to pick London for this one. I've got a CloudFormation stack which ends in .dev. Just use a SAM bucket. And the important thing to set is this watch command. And so this watch command is going to look for any changes and then allow me to update them quickly. So it's just telling me what it's going to be doing. And then basically it does a build of my function again and says here, finishing syncing Lambda function. So what can I do with that? My application builder has now sort of updated, and now I can see there is a cloud version of my function, and I can look at a whole bunch of settings and jump to various places to be able to manage that. I can now click on the Invoke Remotely button. So this allows me to remotely invoke. I can now select that local event object or also grab one from the test event that was created in the console. And off I can go, and I can now remotely invoke the Lambda function. And you can see, there we go, I've got Hello World. So what I want to do is I also want to change my Lambda function. So if I was to just do hello Lambda and save the file, you can see immediately this is going to do a quick sync. So even though we're in CloudFormation with infrastructure as code, it does a quick sync of my Lambda function, just the Lambda function code, and that is then running in the cloud. And some BDI people may have noticed the IP address would have changed, so you can tell between the local emulated IP address, and this is the IP address actually running in the Lambda service, which starts with an 18. So this is a quick way to be able to, iterate quickly on your Lambda function. It doesn't have to do a whole CloudFormation deploy. It just uses the Lambda API. Also actually works for step functions. If you're doing a state machine update, it's just going to use the services API to push up the code, so it doesn't have to go through that whole CloudFormation rebuild. So obviously not something you want to do in a production environment, but this is another quick way to be able to test things properly in the cloud, but be able to do things very quickly locally. And then if you're testing, RDS instances or connecting to some sort of third-party API via your VPC, here you've got the option without having to do a whole bunch of waiting. Also, the Explorer view on the left-hand side gets populated with a whole bunch of stuff. So that also allows you to connect to other kind of services. So another thing I spoke about is LocalStack. Now, LocalStack is a separate company from AWS, and they have been building an emulation environment for AWS for a number of years, and it is actually super amazing. They've got, I think, most AWS services that you can emulate, and basically behind the scenes, it spins up Docker containers that allow you to emulate these kind of services. And the cool thing is the integration. We worked tightly with the LocalStack team. Is when you do the LocalStack integration, the AWS toolkit is able to connect to the LocalStack profile. So LocalStack actually just creates a local profile, which sort of makes a mock region for AWS, which is LocalStack, which is running locally instead of the remote region. So like sort of magic, everything you could deploy or look at, you are able to just change your region to LocalStack, and it will do the whole deployment of your infrastructure to LocalStack. So you can see here, for example, this is pointing to a LocalStack environment. It's been through a whole CloudFormation deployment. You can see I've got a Lambda function. I've got an API gateway endpoint, but this actually doesn't exist anywhere in the cloud. This is all being emulated locally. So obviously there's a nice cost perspective to this because you don't have to have cloud resources running in the cloud. You can really mock a whole bunch of AWS services locally. and check how they run. So yeah, LocalStack has been a fantastic company to work with. They emulate a whole bunch of things, way more than the serverless services as well. And so you can even, emulate EventBridge or SQS. And so, if this is a way that you want to do some testing, super useful. And now it's tightly integrated within the Visual Studio Code experience. So we've now built our function locally. Maybe we've used LocalStack. Maybe we haven't done LocalStack. We've done some testing. We've some debugging. We've done a quick deploy into the cloud. Sort of things look all right, but maybe there's some more we can do, or some other kind of places we need to do debugging. So recently we came out with remote debugging. So this is really complicated to set up. You basically check the box. I'm joking, in case you think it is complicated. You tick the box, a whole bunch of stuff gets set up. I'll cover what happens soon. And then click on the remote invoke. Once that's all set up, I have clicked on the remote invoke. And you can see here, it is now going to invoke the function in the cloud and attach a debugger to the live running function in the cloud. You can see I've got the context object and the event object of the function in the cloud. And I can actually do step-through debugging of my function in the cloud, looking at the return object again. And you can see that I get the response back from the Lambda function running in the cloud. You can see that 18 IP address as well is different. So this isn't local debugging. This is remotely debugging in the cloud. And this honestly is cool and one of the best releases we've had this year. And the cool thing is I just tick that checkbox. So when I tick that checkbox, it makes a few configuration changes to the function. It changes the function timeout to 15 minutes because this function does need to keep running while you've got a debug session running and you're hitting F10 or something to go through that iterative debugging. The function is going to run for a little bit longer, so that's what you're going to do. People are saying, oh, that's going to be more expensive. Yes, but it's one invoke, like one single invoke of a Lambda function for 15 minutes. I hope it's not going to break the bank, but that is a change that does get made as well. It adds actually a Lambda layer, sets some configuration code, which basically acts as a proxy between your local IDE, Visual Studio Code, debug environment, and the Lambda function in the cloud. And then in terms of communication, it actually uses AWS IoT Core to be able to do this, basically manage WebSockets under the hood. But you don't need to see that. You don't need to do that. You don't even actually have to pay for that. That's just part of the service. And so that's a sort of technical change that it makes for the Lambda function as well. So the cool thing is now I can do step-through debugging. Maybe, as I said before, I need to connect to a third-party API or something in my VPC or an RDS database or something, which previously it'd be really tough to be able to properly debug something in the cloud. If I'm debugging in the cloud, I can also check my IAM permissions. I can basically check exactly how the function is going to run. So this is a great way to have that live debugging in the cloud, and it's really sort of simple to set things up. So that's remote debugging. It's only a tick box. Once you uncheck it or remove away, it then removes the Lambda layer. And undoes all of that configuration changes. One other change it makes to the function is it actually publishes a new function version. So it's not as though it is using your not using your latest function version. If that's particularly useful if you're using versions and aliases. So you've got your live production version coming into one kind of thing. You do a debug session, it's actually another version of your Lambda function. So it's not actually messing with your live running Lambda function. So we've done some debugging in the cloud. That is super cool. The next thing, well, we're actually now all confident this is going to work. Why don't we deploy this to production? So again, on my application builder, I can just click on the deploy, select the parameters. I need to select a region as I was going to do. So I'm going to run this in London as well. I'm going to create a production stack. And so now what this is going to do is it's actually going to do a full CloudFormation deploy. I've tested everything. I should be confident that it's going to work. It's been through, all my sort of local software development and everything. And you can see here, initiating deployment. And this can be my sort of production stack of my environment. I've still got my dev stack. If I want to, I can switch back to that. And you can see here, once it's done, the application builder is then going to be refreshed. And you can see it's now the prod version of my Lambda function. Again, I could invoke that remotely. You can see I've now got the prod function name. I can select the local file or whatever file I needed to do for the event object. And off I can go and remotely invoke that Lambda function. This is now the nicely sanitized production version running in the cloud. And there you go. I've still got my Hello Lambda and coming back. So really nicely, I've done all of this. I haven't had to leave my IDE. I haven't had to jump to the console to make any changes. I haven't had to, context switch back and forth to be able to see all these different kind of things. Super useful. So my function is now running in the cloud and I want to check that all things are working. And so, well, obviously something I want to do is I want to look at the logs. So what I can do as well, there are two different ways I can look at the logs. Sometimes I click, it doesn't click. I can look up here on the Explorer view and I can see all the other different things that are happening. I've got my dev function, my prod function, and I can actually look over here and then remotely invoke from there as well. But I can actually then search the logs. So I can just click on the button over here and I could search the logs from, maybe the last 15 minutes, whatever region from a particular function. And there it's going to just pull out the logs as if I was going to the CloudWatch Lambda console and looking over at those CloudWatch logs. So that's super useful. Doing a bit of testing, I can look at the logs locally, and that would all be cool from the Lambda function. But, we can take this a step further. We can actually look at the CloudWatch live tail. So as we were doing this in the console, I'm curling or doing other kind of things from a Lambda function. Instead of, asynchronously connecting to those logs, I can just, invoke the function a couple of times and the log stream just comes immediately from our function. So the live tail logs, not only available in the console, also available IDE. Just another, cool way that I'll be able to look at my application, curl something, drop a message into SQS and be able to look at that as well. So it just makes it a bit easier to get your logs as well. So a bit of a whistle-stop tour that we're going through all the Lambda local IDE enhancements. Hopefully they're going to be useful. The Lambda team is taking many goals and actually improving the local developer experience. So we'd love to hear your feedback on this and then other things that are happening. People asking about other infrastructure as code support. That is something we are certainly thinking about and wanting to do. CDK is obviously very popular. That would be cool. Generally, what this is doing is exposing a lot of capabilities for SAM. So SAM is the serverless application model, sort of one of our infrastructure as code tools. But the thing is, SAM is actually just CloudFormation behind the scenes. So a SAM template has some abstractions to build serverless applications, but you can also, use any just plain CloudFormation template. Point it here, and the Visual Studio toolkit will be able to look at that and be able to populate the things in the Explorer, even if you're not actually using SAM. It's a bit clunky at the moment, but there's also a bit of a hack when you do CDK, because CDK is CloudFormation under the hood, and when you do a CDK generate, or when CDK generates a CloudFormation template, you can actually point this to that CloudFormation template, and then be able to do a lot of the functionality over here because of the local debug and the local testing and all of that functionality is just on a CloudFormation template. So that would work as CDK as well. I appreciate it's a bit clunky at the moment. Hopefully we'll be able to make that a little bit better. So that's all the local kind of stuff. And then there's some cool new Gen AI kind of things as well, where you're able to use Gen AI to be able to improve building serverless applications. So we've come out with this AWS serverless MCP server. Has anybody been playing with MCP servers of sort of any ilk? A few people. Okay. So let's just quickly talk about MCP. So MCP is basically the Model Context Protocol. And this is a sort of new AI protocol, newish AI protocol that came out from Anthropic. And we all know, if anybody's played with AI assistants or any AI kind of thing, is an AI needs to connect to something else. And it may be some tools, it may be some information, it may be your private information in a VPC, it may be other kind of things. It needs to access information, but also it maybe needs to do some tasks. It maybe needs to do a deployment. Maybe it needs to update a database. Maybe it needs to create a sales record in Salesforce or a payment in Stripe, all these kind of things. And previously, this was tough because you had to manage APIs, were they REST, were they GraphQL, was it just a SQL statement? And so MCP is a common protocol for AI assistants to be able to connect to external sources to do a whole bunch of stuff. And everyone in the world is basically been creating these MCP servers, which you connect to from your local coding environments or from Claude Code or from Amazon Q, Amazon QCLI, a whole bunch of services. And you can see a huge number of names here. If you're using Neon or using Fireproof or you're using, Slack or SQLite, all these kind of things, they're building MCP servers so your AI assistants can work with that. So obviously, we want to help you build serverless applications using MCP, and this sort of gives you AI superpowers with serverless expertise to help you build serverless applications. And there's contextual guidance specific to serverless development. There's help to create, build, deploy, and test applications. There's tools to also build web apps, use infrastructure as code. There's observability, and there's more coming. I think there's some event source mapping help. It may be out. Or maybe, don't quote me if it's not out. I'm sorry, I'm spilling the beans. But there is some event source mapping things either out or coming out soon where you'd be able to ask this MCP server in natural language to set up an SQS or a Kafka event source mapping and be able to give it some sensible parameters and make sure that everything is all up and running. So I'm going to I have just made this demo slightly shorter because otherwise there's a bit of watching AI assistants do their thing, which may not be too exciting. So basically I'm using Amazon QCLI, which has actually been really helpful, but you could use Claude Code, you could use any tool that supports MCP servers. And basically, I just set up, it's a little bit of configuration script that says use the MCP server, and that's how it runs. And then I've gone in and I've basically listed all the various tools, which is the helpful things that this MCP server can provide. And I've just trusted them all just to be simple. But of course, you can go in, turn them on and off, and be as secure as you need to be. So the terrible coder I am, I want to vibe code like the worst of them. And so basically, I'm going to go do the exact prompts that I wrote. So I said, I want to build the backend for a new to-do application in a new workspace. I want to be able to add, list, and delete to-dos, and then just ask you a question. I don't want to build it yet. Like, would Lambda actually be a good choice for this? So you can see I've typed the prompt at the bottom. I've got all the trusted tools above. I want to build a to-do list web application. And off it goes. It has a quick think and goes, I'm going to use the get Lambda guidance tool. And it's got some information about what my prompt was. It says, well, yes, actually, Lambda would be a fantastic choice for this because it is event-driven. There's no server management. And it's given a recommended architecture with API Gateway and Dynamo. Has come up helpfully with some considerations. Each operation needs to complete in 15 minutes. Maybe there's some cold start things you need to think about. But it's like, okay, well, that's a good start. And hopefully it would be, intelligent and opinionated. If my prompt had been about a, long-running batch job or that kind of thing, I would have said, well, no, Lambda's not actually the best use case for this. Maybe use something like ECS Fargate or some other serverless service. So just a way that you can get a bit of guidance and, understand which services may be helpful to use. So the next prompt, I'm not going to demo this, but I basically asked, I later want to deploy the application to AWS, which infrastructure code tool would be best for this. So it basically came back and said, well, SAM is going to be the best one. It actually came back with a helpful table between SAM, CDK, and the CLI. And it said, look, this is a pretty simple application. SAM's going to have some good abstractions. It gave some good information about when you would want to use CDK. If you want to write your infrastructure as code in a programming language, if you wanted to be able to use higher constructs. But, CDK, there's a bit more to install. It's a bit different. So at least it gave you some useful information to be able to make that, choice. So then I said, okay, great. Can you go and please create my app? Now, I haven't looked at any code or understand any code. Let's see what it does. So there's the prompt. It's how to think. I'm going to open the file explorer. You can see nothing's actually created. And off it goes is actually downloads that SAM from using SAM init, that example, infrastructure as code and an application. And you can see it's building a whole bunch of files. You can see it's reading what it's got there. Here I have now created a package.json file. It needs some dependencies. I've got a Lambda function for to-do, for adding to-dos, for listing to-dos, and another one about a pop-up for deleting to-dos. So this is literally live creating my Lambda functions. It's got some test events. That's certainly going to be helpful. And this is just literally just generating code, a sort of vibe coding style without me having to do anything as well. It then says, okay, I'm going to build my application. So behind the hood, it's going to run SAM build. There are a whole bunch of parameters. I don't know what it is. Oops. It realizes it's got an error. The billing mode for DynamoDB isn't correct. So it realizes it's got a problem, fixes the template and does another build and realizes, excellent, that has now worked. So as helpful as our AI assistants are, it's done a whole sort of document which has understood exactly what has been built, my source folders, the features that have been implemented, the fact that I've got DynamoDB, some test things. Excellent. So, that was literally one prompt. It's used the MCP tools to understand the best way to build a serverless application. It's, picked a decent architecture for it as well. It's built it. It failed with a DynamoDB setting, fixed itself, off it went, and it's now built a skeleton of an application with some README files as well, and test events and, in infrastructure as code. So that is pretty cool. Now, I haven't created anything myself, not a single file. This has all been created from scratch. So the next thing I can do, well, can I deploy this? And this will actually use SAM deploy behind the scenes. Again, I don't have to type the commands of -- whatever and do all this kind of thing. Off it's going to do and deploy that. So next I've entered a prompt and said, well, I want to try this application out. Can you just create 5 helpful to-dos? It was a bit meta. I said, can you suggest 5 to-dos to improve this application? I basically runs a whole bunch of curl commands, adds them to the database, and they're available then to be able to be used. So next up, I said, well, this is running. I also want to, can you check the logs and metrics of the to-do app? So it ran through a whole system of, invoking the application, making sure it all worked. I said, well, it did actually come back and say, well, there's some issue with cold starts over here, which is surprising. It's a Node app, shouldn't really have many cold starts. And so I was like, well, I know Power Tools is an awesome library for adding observability. And so instead of having to go in and configure it, I just add that prompt, please add observability with Power Tools, and off it went. It got super excited and added X-ray logging and tracing and custom metrics and a whole bunch of well-architected good practices from observability. It's got the information, what it needs from the MCP server, and added all this functionality as well. It even went above and beyond and added actually a CloudWatch dashboard, which I didn't even think of doing. So yeah, good on my assistant for taking the next step. So the next thing is over there. I said, okay, it's a back-end. I'm not a front-end developer. I'm a pretty probably, ropey back-end developer at the best of times anyway, but front-end is way beyond the pale. So I was like, well, can you write a simple but snazzy front-end? May as well be snazzy. You don't want a boring front-end that I can run locally, that I can then connect to this application to be able to see what it looks like. Again, these are all the prompts I've written. I haven't done anything else. So off it goes. It then created a whole bunch of code. I just, then did an npm install, slightly fast forwarded. So it's installing a whole bunch of dependencies, and then I can, npm start run this application locally. So told me what's going, and here I browse it, and this is the snazzy front end that's created. So I can see it's got those 5 separate tasks that have been added, and I just add another task to say do more with serverless and MCP, and I can add that to do, and off we go. This has now been added to my database. You can see I've got it over there. That has been pulled from the front end. I can go delete that as well. So yeah. How simple was that? I've got a really quite well architected, obviously I'd want to go and check it and make sure that it all behaves and works, but I've got an API gateway on the front end. I've got a Lambda function doing the processing, or 3 different Lambda functions doing the different processing. The IAM permissions are set up. I've got a DynamoDB table set up, the partition keys, any sort keys and all that is done on my behalf, and I have this application. Obviously a simple example, but hopefully you can understand that you could use these MCP servers to, enhance and build your own applications and be able to help you at least getting on your way. So last bit is just to talk about some sort of tools and tips and other kind of things that can hopefully improve your developer experience and make it all a little bit easier. First of all, on the left-hand side is a whole bunch of AWS MCP servers. Been chatting to some people today. They've been using some helpful ones. There's the AWS knowledge base, AWS documentation. And so that is actually really cool. You just connect up to that, ask any questions of the documentation. What is the default quota for this? What is the, any kind of questions of the documentation without having to run through pages and pages of documentation. Because I know documentation is amazing, but it's very comprehensive and very service-based. So this is obviously a nice way that you can collaborate with the documentation. APIs, Cost Explorer, DSQL, the new sort of distributed SQL has got one, so you can manage that. So yeah, huge amounts of MCP servers from AWS just to be able to use natural language to be able to either provision stuff. There are some settings you can set to say, non-mutating operations to keep it safe, or just, good example is, can you check the CloudWatch logs for the past, 15 minutes, 3 hours? Are there any errors for the service? You literally just type that out, and you're not having to do a CloudWatch logs, inside query and doing all that kind of thing. Super helpful to just be able, as you're thinking as a developer or an operator, ask questions to AWS infrastructure and get the answers that you need back. On the right-hand side, something we haven't covered today, but obviously you could run all these MCP servers in a serverless way, using Lambda or Fargate or even Agent Core, which is a new thing, a whole another thing we could talk about. But yeah, that's just another QR code with a whole bunch of, if you want to run your own MCP servers in a serverless kind of way. Step functions, the Workflow Studio. A number of people raised their hand earlier who are using step functions. The Workflow Studio is, I think, one of the best UI interfaces AWS has created. And I'll be entirely honest to say we don't have a great history of building awesome UI experiences. So yeah, the step functions team knocked it out the park, being able to have the really great visual workflow. Whereas Matt showed earlier, see all the red lines, be able to look at something that's gone wrong, look at the input, look at the output, be able to create your state machines, drag and drop, connect to SDK things, retry logic, all of that in a visual way. And now you can all do it locally. So not having to jump into the step functions console. This is all available, and you can see I'm looking at Lambda. These are all the different Lambda kind of things I can do and drag them into my state machine on the right. Again, this is all locally. It's also been enhanced to be able to do some of the substitutions. So yeah, a bit more of a tangent for that, but that makes that a little bit easier. I mentioned Power Tools before. If you are developing in any of these kind of languages, Power Tools for Lambda is really, I wouldn't even say more than encouragement. It's really a must-have to make stuff much easier. It's got a whole bunch of functionality, particularly if you're doing batching or using idempotency. Can't remember, there was a talk earlier talking about, Jan's talk was talking about using idempotency earlier. Such a great thing to be able to use event-driven architectures, to be able to do anything that may update something twice. So yeah, Power Tools, your friend, a whole bunch of libraries that are included in that for the batch handling. API schemas, be it GraphQL or REST, or HTTP APIs, secrets management, caching, feature flags. There's a whole bunch in there. So yeah, seriously, take a look. Talking infrastructure as code, there's a serverless patterns collection. There are over 900 now infrastructure as code patterns. So this is either CDK or SAM or Terraform. It's across all languages, all runtimes. You can filter if you're wanting something for, Kafka and EventBridge. Select on that. It's not just Lambda related. An infrastructure as code template you can just grab. It's all open source, all available on GitHub. If you want to, provide your own templates and help the community, that would also be awesome as well. So yeah, serverless patterns collection, super handy. And so yeah, just some tips. Set up your local CLI tools, get your IDE working, and I'll be able to turbocharge your development. Get to infrastructure as code as quickly as you can. You'll obviously be able to test and debug locally your functions. Also in the cloud, hopefully we've made the handoff between the two much easier. And the different options you can use to do different things, but hopefully you can find one or many of them for your use cases as well. To be able to confidently move to the cloud, and obviously, why not get a bit of help with Gen AI? So I have talked quite quickly. There's a lot to cover because we've been doing a lot. I'm happy to take more questions later and delve into it. But yeah, we started talking about, even the business thing of why doing serverless, developer experience and serverless together, you get better developer experience. Using serverless can hopefully, even beat that Deloitte stat. Being able to work with the inner and outer loop, console IDE and getting to automation with a sort of run, walk, crawl and fly. Good, decent amount of demos. Hopefully that will be useful to be able to visually see that rather than just reading it through on a blog post, and some cool tips and tricks to be able to end it all. The road ahead, this I do in every talk because the whole serverless team is sort of working hard to be able to add the well-architected goodness as part of the service, really focusing on developer experience, Lambda step functions, EventBridge and other serverless services. Developer experience is a really high focus because we know that can always be improved, improved controls over the services, how you can manage them, and then, always more and simpler and more broader integrations. And it just hopefully keeps getting better without you having to do anything. The last one is a Builder Center, a Builder ID. So Builder Center is a new place for communities to gather, new place that you can be able to, sign up to Amazon Q. In the future, hopefully not spilling too many beans, but for signing up for some AWS events, you'll be able to use a Builder ID. I'm sure everybody enjoys filling in their home address information for the umpteenth, 100th time for another AWS event. Hopefully in the future, this is going to be a single profile that will be useful. Serverlessland.com is a website my team run, and so this is sort of all information we can jam in, a good aggregation point for blogs and videos and landing pages and what's new. And it's got the patterns collection. It has got just a whole bunch of stuff. Serverlessland.com. I sort of say it's the best place for learning about serverless on AWS. And last of all, thank you very much. Hopefully you're all alive. There's more Serverless Espresso if you need another pick-me-up after I've drained you through this talk. Really appreciate you spending time with us today, and always a pleasure to be in Cardiff. So thank you very much.